Hello there. For this video, we'll be evaluating limits by rationalization. So first, recall that in the previous video, we have shown that we can solve this limit, which we know to be an indeterminate, by factoring. Indeed, what we did in the last video is that we forced our way to factor this numerator into 2 minus square root of x times 2 plus square root of x. Cancel out the 2 minus square root of x's out here, and we're left with 2 plus square root of x. Upon direct substitution, we got 4. So this is what we got last time. But take note that this isn't always that easy to factor when we have radicals. What we can do instead is apply rationalization. So let's clear this out. And in a nutshell, rationalization is the process of removing a radical in either the numerator or denominator. For instance, if we have 3 over square root of 3, what we can do is we can multiply square root of 3 over square root of 3. So note that we can do this since a number divided by itself is just equal to 1 as long as these numbers are not 0. So by multiplying this, we'll have 3 square root of 3 in the numerator and 3 in the denominator. Divide this 2 and we obtain square root of 3. So as you can see, we were able to remove the radical in the denominator and it is now instead in the numerator. Now given this, the problem in here is that we have binomials. As you can see, the radical out here is in a binomial. So what do we do? Well, we can apply something that we know in the past, and that is the sum and difference special product. That is a minus b times a plus b is equal to a squared minus b squared. So this is useful since a radical, especially a radical without an index, we know that it is automatically assumed that the index of this radical is 2. So upon squaring this one, we can cancel the radical out and we obtain x. That is why it is useful to use this concept. So in this one, what do we multiply to rationalize the denominator? Well, we can multiply the sum version of this, since as you can see, this minus version is multiplied by the sum version. So we'll do just that. So we have here times 2 plus square root of x over 2 plus square root of x. Again, we can do this since a number divided by itself is equal to 1. And take note that at values near 4, near x equals 4, 2 plus square root of x is clearly not equal to 0. So we can really do this one. So as you can see, since we have the difference version here and the sum version out here, upon multiplying these two, we obtain 2 squared minus the square of square root of x, which is equal to 4 minus x. And so we'll have in the denominator 4 minus x out here. Then observe that we have a 4 minus x as well in the numerator, so we can divide these two. And we can do that since we're just dealing with values near 4 but not exactly at 4. So we know that 4 minus x is not 0, so we can divide it clearly. And so we'll be left with 2 plus square root of x. Now we can easily plug in the value of 4 in this function. So we obtain out here 4 by direct substitution. And so we got the same answer in what we had in the factoring method. So that is how we apply rationalization in limits. Now let's try out more examples applying this concept. So let's have this first example. Take note that this time we'll rationalize the numerator instead of the denominator. So before we start, feel free to pause the video so that you can try this one first on your own. So let's start. So first, upon direct substitution, so if we plug in 1 in this function, you can verify that this will become 0 over 0. So it is an indeterminate. So let's try to rationalize this one. So first, since we have the radical out here, we need to rationalize this numerator. It might just seem scary a bit since we have a binomial inside this radical. But what we can do is we can treat this one as a single term. So if we do that, what do we need to multiply out here? Well, we can multiply the square root of x plus 8 plus 3. So this is the conjugate. So take note that when we change the sign out here, we refer to that expression as the conjugate. So upon doing that, so we'll have here the square root of x plus 8 plus 3 over the square root of x plus 8 plus 3. So upon multiplying that in the numerator, so we'll have here the square root of x plus 8 square minus 3 squared. So when simplified, this is x plus 8 minus 9. So we have here that. Then simplifying the numerator, so subtracting this 2, and we obtain x minus 1. So we have an x minus 1 in the numerator and in the denominator. So we can divide that 2 and we'll be left with 1 over the square root of x plus 8 plus 3. Now in here we can easily plug in 1 now out here since we won't have any complications. So by doing that, we have here 1 over the square root of 1 plus 8 plus 3. And we'll have here 1 over the square root of 9 plus 3, which is equal to 1 over 3 plus 3, which is 1 over 6. So the answer for this one is 1 over 6. So that is by direct substitution. And that is the answer for this given limit. So I hope you got that one right. Now lastly, let's have this. So in here, observe that we have two radicals out here. It might seem harder at first, but take note that the process remains the same. So again, first, feel free to pause the video so you may try this one out on your own. Okay, so let's start. So again, first, you can verify that by direct substitution of 2 in this function, we'll obtain 0 over 0. So we have an indeterminate. That. So let's try to apply rationalization out here. So what we can do is we can treat this one as a single term, and so is this one. So what do we multiply in the numerator this time? We'll just multiply the sum version, which is the square root of 2x plus the square root of 6 minus x. So that is what we'll multiply out here. As you can see, we have here that one. And from here, we know that multiplying this will give us a difference of 2 squares, where in this term, we have square root of 2x, and in this one, we have square root of 6 minus x. So this, when simplify this, so we'll just cancel out the radical out here. and we'll be left with 2x minus 6 minus x. So we'll have that one out here, and then we can simplify this. So distribute the negative sign out here. This becomes 2x minus 6 plus x. So add the 2 x's out here. So we have here 3x minus 6. This one. And take note that we can actually factor out the 3 in here to obtain 3 times x minus 2. And what can you observe? We have an x minus 2 in the numerator and so in the denominator. So we can divide that out and we'll be left with 3 over the square root of 2x plus the square root of 6 minus x. Now we can easily plug in 2 out here as we won't have any complications anymore. So we'll do that one. So we have here 3 over square root of 2 times 2 plus the square root of 6 minus 2. This is equal to 3 over square root of 4 plus square root of 4, which is equal to 3 over 2 plus 2, which is 3 over 4. So this is the answer. And yeah, so that is how we evaluate limits by rationalization. To formally end this, here's an exercise that you can work on. So, whoa, this might seem really hard now, since we have radicals everywhere. Radicals in the numerator and radicals in the denominator. So, yeah, it might seem scary, but take note that the process remains the same. But as a hint, this time, so let's write it that here as a hint, you'll rationalize there twice there with an exclamation points. So you'll rationalize this one and you'll rationalize this one. So it might seem to be a lengthy process, but you'll see that after doing that, you'll be able to cancel something. And yeah, that is another hint. There is an answer to this one. Or, I mean, the limit does exist in this one. So, I hope you try this one and feel free to comment down below if you are stuck in your solution, or if you have an answer, you can share it in the comment section down below. So yeah, that's it. I hope you learned a lot from this one, and yeah, that is all for this video.